Hello everyone, ECE410 Power Electronics. Welcome back to the lecture 1, part 2. So we're going to talk about some challenges and how to deal with it. One of the challenges is that uh, power is changing. So we're using more and more power electronics device into the power processing. In 10 years, the whole electrical energy would be processed by the power electronics because that's efficient and easy to control. And without power electronics device, you cannot change the form of energy, right? So it's very delicate and cost effective to do that. And then so power electronics engineer needs to create tools that leads to a very good implementation of sustainable energy use. So one of the things, like electric car, we're going into electric car now, but electric car uses a lot of power, right? Uh, and how to make it reliable and safe and efficient, that needs a power electronics engineer who has a sound knowledge and also very innovative. So we're missing that portion here because we have very few power electronics engineer in the industry right now. There are some things. Let's think about this over here. Where our digital world is going towards a low power every few years, right? So a near long term goal is 1 volts 70 watt, and longer term goal is 0.5 volts and 70 watt. So if that happen, if that is the case here, you have to carry to supply their 70 watt with zero point 0.5 volts, you need to have 140 amps of current going through some wires, right? So you cannot do that. So you have to think differently. How can you do that, right? And sometimes we use diode to supply power. If we try to use diode to supply zero point 0.5 volts, look at here, diode takes almost 0.7 volts. So basically, we're getting is 40% efficiency. This is not the good solution now. You have to think about a different solution to do that. When digital sector is going lower voltage every few years. Also, inductance is the biggest enemy for that too. Typically, a inductor for a wire with supply has 5 nanohenry per centimeter. Nanohenry does not sound big, but it will be a very big problem if you have a higher frequency. We're going to talk about that. So 5 nanohenry per centimeter is not a big nanohenry, right? But it's not a big deal. But when your frequency comes into the play, it's a big deal. So think about this here. You're working here 300 megahertz microprocessor, all right? That current in the microprocessor circuit can go up and down 40 amps in just a few clock cycle in the microprocessor. So if you have a clock cycle like nanoseconds in here, so if your 40 amp swing happening in nanoseconds, that means you're changing 40 amps over DIDT over here to be 4 times 10 to the power 10 amp per second. There's a change here. There's a change here, right? So now, if you incorporate that just for 2 centimeter wire in the circuit, so 2 centimeter wire, we have 10 nanohenry, right? So let's think about how much voltage is generating. So VL, induced voltage, L DIDT, you know this equation, right? So if you do that, 10 nanohenry, right? Nanohenry is handy over here now, right? Then you have this one, you have that value here, 4 times 10 to the power 10 amp per seconds. If you do that math here, now you'll have 400 volts. Look at that, it's generating 400 volts. So your digital circuit microprocessor cannot handle 400 volts. It's gonna destroy anything in its way. So that's the problem with high frequency, high current requirement, and with the inductance in the circuit. All right. So what is the solution? Solution is that you design the processing circuit in the chip itself. So you don't supply anything. So in the chip, we have a processing unit right there to do that. In most of the microprocessor, they have the PWM circuit in there to do the processing. That's the reason why you do that. So now it's getting more and more popular to all the chips should have their own processing unit inside the chip, so you can avoid voltage insurgent into the circuit. Again, I talked about this earlier. We need more people with the sound knowledge that can make the power electronics circuit inside the car secure, stable, and efficient. So that's why, because that produce and process a higher amount of power in the car circuit. And as I said, the chip over here, that they don't want to have the power coming from outside. They want to get the power from outside, but process inside the chip, so you can minimize the transient of voltage that can destroy the chip by itself. All right, and there are higher carrying power circuit out there to handle higher current, higher voltage. IGBT can basically handle 1700 volts and 600 amps right here. That is insulated gate bipolar transistor. It's basically a combination of MOSFET and BJT. And control circuit, this is the old circuit here. There's a new one here. So you can see that with the digital help, your circuit will be a lot smaller and also a lot efficient. 21st century, we're trying to get more and more into renewable energy, more and more sustainable growth. That only can happen if we have a good power electronics backup to process all the energy coming from like an uncertain source, like your solar, your wind, your tidal, so all uncertain source. So we need power electronic circuit to handle those and make it certain. So that is one of the applications. Other application is we're going more and more into smaller, very low voltage digital circuit. We need the processing circuit inside the chips. We need to make very sophisticated processing circuit inside the chip to handle that. And also electric vehicles, we need to do more research in two front. One is make the circuit and processing more efficient and safe, and second one is make the storage device like battery more secure, safe, and long storage of energy. So those are the challenges for the 21st century that we're living right now. So your job as a power electronics engineer to get into these challenges and make it better for the future. So power electronics, you cannot think about anything else out there, like cannot think about renewable energy at all without power electronics, because power electronics is in the heart of renewable energy. And you cannot think about electric car without power electronics. We cannot think about, let's say, digital circuit, low voltage digital circuit without power electronics. So power electronics is in the heart of everything you can think of. So that's why you need good, very sound power electronics engineer in the future. So I'll see you in the class, and I'll see you for the, I'll post the lecture 2 video soon.